Hello everyone, welcome to our channel Physics 4AP. So as we are getting success in completion of the chapter that is the carbon and its compound, and in our previous episode we have discussed about the nomenclature, that is how to draw the structure with the given carbon compounds and how to name the carbon compounds based upon its structure, that we have seen in the nomenclature. So now in this episode we will discuss about the chemical properties. So in this chemical properties we will discuss about the combustion reaction, oxidation reaction, addition reaction, substitution reaction, and also the preparation of alcohol, ester and acetic acid. So ester will be seen in the next episode. Now we will see the preparation of alcohol and acetic acid and these four types of chemical reactions. Now let us move on to our main topic, the chemical properties of carbon compounds. So in chemical properties of carbon compounds, that the first thing that we are going to discuss is the combustion reaction. So the combustion reaction is that the carbons or the carbon compounds are burned in the presence of oxygen to give carbon dioxide, heat and light. So heat and light is considered to be called as the energy over here. So carbon and its compound, whether any compound, any organic compounds, when it is burned in the presence of oxygen, so it gives carbon dioxide along with heat and light. So this type of reaction is called as a combustion reactions. Now example, if we see here, we have a carbon, when it is react with the oxygen we get carbon dioxide and plus some amount of energy is in releasing out. As well as if we do C2H6, which is called ethane. So when ethane is being reacted with oxygen, that is when it is burned in the presence of oxygen, so we get carbon dioxide, water and energy. So as there is no hydrogen molecules over here, so we cannot get water over here, but in remaining carbon compounds we are having the hydrogens, as due to the presence of hydrogens, when it gets reacted with the oxygen, that is the oxidation in the air, so we get water molecules over here. At the same time alcohol, which we call as ethanol, so CH3CH2OH, so ethanol, when it is react with oxygen, so we get carbon dioxide plus water plus some amount of energy. So the energy which is released here is in the form of heat or light. And if we see here, when we burn the saturated and unsaturated hydrocarbons, what happens? As if we see the saturated hydrocarbons, which are called as alkanes, so which are called as the alkanes or also called as the paraffins. So they are also called as the paraffins. Why? Because they can be easily split out. So the paraffins, the word paraffins is nothing but which can be split out easily with little amount of energy, is called as paraffins, and they are called as alkanes. That means all the saturated hydrocarbons are alkanes, which are also called as paraffins, like example LPG. So when they burn out, they produce a blue flame over here. So the blue flame, why does they produce, is due to the complete combustion. So due to the complete combustion, we are having a blue flame over here. Like in our home, if we see the stove, if we burn the gas, the LPG gas, you see the blue flame. So the blue flame is why? Because of due to the complete combustion of the carbon particles present in the LPG gas, and that is why, so all the carbon particles which are present in the LPG gets burned out. As the temperature rises, the vibration between the particles also rises up and produces a blue flame. That means when it gets vibrate, it has a certain frequency, so that frequency will be equals to the color of blue over here, and that is why we are getting a blue flame. So all the saturated hydrocarbons like alkanes, example LPG, they produce a blue flame because due to the complete combustion. So as they get complete combustion, the particles which are present in the hydrocarbons in that LPG or the saturated hydrocarbons, they all get burned out. So when they burn out, the temperature rises. When the temperature rises, the vibration of these particles also rises up, and that vibration that makes a certain frequency which is equals to the color of blue over here. And at the same time, if we see the unsaturated hydrocarbons, they are also called as aromatic compounds, or which we call as olefins. Olefins, that is unsaturated, or called as alkenes and alkynes. So alkenes and alkynes, which are double bond and triple bond. So the unsaturated hydrocarbons like kerosene, coal, petrol, diesel. So all these are the examples for unsaturated hydrocarbons. So when they burn out, they produce a yellow flame along with the soot. That means whenever you burn the petrol, you see the black smoke coming out of it. So that is called what we call the soot. And why does the yellow flame and soot comes out? Because due to the partial combustion of carbon compounds. For example, if we have 100% of carbon compounds in a petrol or a diesel, so partially it will be burned out, like, or 80% of the carbon particles will be burned and produces a yellow flame, and the remaining 20% will be come out in the form of a soot over here. So why? Because as the particles are not completely burning up here, as they are burning partially, so due to that certain frequency it produces a yellow color flame. So some of that them also will produce different colors based upon the nature of the compounds which we have, like copper, which will produce a green flame, or copper chloride, which will produce a green flame, and strontium chloride, which produces a red color, reddish color, and sodium, which produces yellow color. So all that is due to the vibration of the particles. So the particles get vibrate, so they produce a certain frequency, and that frequency produces a certain wavelength of color over here. So the saturated hydrocarbons produce a blue flame due to the complete combustion of carbon particles, as well as the unsaturated hydrocarbons like coal, kerosene, petrol, they produces yellow flame along with the soot because of the partial combustion of the carbon compounds. So this is about the combustion reactions. Now next move on to the second reaction, that is the oxidation reaction. As you may know about oxidation is nothing but the addition of oxygen or the removal of hydrogen with the help of the oxidizing agents is said to be called as oxidation reactions. So here we have an example, like if we take an ethanol, that is CH3CH2OH ethanol. In the presence of the oxidizing agents like alkaline potassium permanganate, that is KMnO4, and plus heat, and also acidified K2Cr2O7, it is called potassium dichromate, and potassium permanganate, in presence of these two oxidation agents. So here the hydrogen is being removed out, that is H2 is being removed out of here. So the removal of hydrogen is called as oxidation. As in this ethanol, or what we call ethyl alcohol, if you remove the hydrogen from this compound, like if you remove, I'm closing it, so if you remove the compound, what can you see here? You have CH3CHO. Now if you combine these three, you get CH3CHO, which is called as ethanol, that is aldehyde, or also called as acetaldehyde. So it is an aldehyde over here, but still reaction is not completed. Again further reaction, further oxidation, then it converts into CH3COOH. That means here when we add oxygen over here, by adding of oxygen, so here oxygen is being removed out, as the hydrogen is being removed out over here. So you just keep it side, and here we are adding oxygen to this, to the ethanol we are adding oxygen over here. So when we add oxygen to the ethanol, as two hydrogen atoms are present in this, one hydrogen atom gets combined over here to form CH3CO, the O which comes over here, OH, CH3COH, which is called ethanoic acid, or also called as acetic acid, Now where does another oxygen moves out? So another oxygen moves out as one hydrogen is being removed out, the one of the oxygen atom combines with this hydrogen to form H2O, that is water. So is it clear with this reaction? That is the oxidation reaction. So it is oxidation means addition of oxygen or removal of hydrogen. So in this first, the ethanol, we are removing the hydrogen with the help of the alkaline KMnO4 and acidified K2Cr2O7, which is called the oxidizing agents. And when the hydrogen is been removed out, again further oxidation, this ethanol is been converted into ethanoic acid and releases some amount of H2O molecules into the atmosphere. Now if you see in this reaction, that is the combustion reaction, so here also we are adding oxygen, that is the addition of oxygen is going on. That means all combustion reactions can come under the oxidation reactions. All the combustion reactions come under the oxidation reaction, but all oxidations are not combustion. Have you understood what I am saying? So they may ask in a competitive examinations, or they may ask in some interview questions like based upon the organic chemistry, those are going for the interviews. So they may ask this, all the combustion reactions can be said as oxidation reaction. Is it true or false? Yes, it is true. So can we say all oxidation reactions are combustion reactions? No. Why? Because in combustion reaction we need to get carbon dioxide over here. But in this oxidation reaction, we are not getting carbon dioxide any of here. So that is why we can say that all combustion reactions are oxidations, but all oxidations are not combustions. That means they are not need not to be called as the combustions over here. Now is it clear with the chemical properties of the carbon compounds? One is the combustion and another one is the oxidation reactions. So these equations need to be memorized very easily. No need to memorize. When you take alcohol, so in that alcohol remove one hydrogen, so due to the oxidation reaction we are removing one hydrogen. So when you remove one hydrogen you get CH3CHO. What are the remaining you are having here? Write it down. And again addition of oxygen, so further oxidation you just add the oxygen. So when you add oxygen, one of the oxygen atom gets combined in between here and form as CH3COOH, and plus H2O is being released out into the atmosphere. And next, moving to the next reaction is the addition reaction. So addition reaction is quite opposite to oxidation, as in addition reaction is nothing but we convert the unsaturated hydrocarbons. So unsaturated hydrocarbons like the triple bond or double bonds, they have been converted into a saturated hydrocarbons with the help of a catalyst. With the help of a catalyst, we convert the unsaturated hydrocarbons into saturated hydrocarbons. That if it is a triple bond, we need to convert into a double bond, and if it is double bond, we need to convert into a single bond over here. The help of a catalyst. So what is a catalyst? So the catalyst is, it is a chemical or a compound or an element, whatever it may be. It is used to increase or decrease the reaction. So that means the reaction, the rate of the reaction, whether it should be done faster or whether it should be done slower, it can be done with the help of the catalyst, but that catalyst is not participating in the reaction itself. It is not involved in the reaction, but it makes the reaction, the rate of the reaction faster or slower, which is called as the catalyst. So the catalyst which we are using here is Ni, that is nickel over here. Now if you see here, CH3 bond C, triple bond C, bond CH3. So we have a compound which is of unsaturated hydrocarbon, that is alkyne group. So 1, 2, 3, 4, that is 4 carbons, so but, as we have a triple bond ine, so all are hydrocarbons E. So as it is in the second position, so we write it as 2-butyne. Now in the presence of nickel catalyst, that is hydrogen is being added over here. So that's what I said. So this addition is quite opposite to oxidation. So in oxidation we remove the hydrogen, but here we add hydrogen over here. So when we add hydrogen, as we have H2 molecules over here, it's very simple. See, as H2, 2 hydrogens, one hydrogen will get combined with this one hydrogen atom and with carbon atom, and another hydrogen atom will be just combined with this carbon atom, and the bond gets decreased. So that is what we get here. CH3 bond CH double bond CH double bond CH3. Now what happened here? The triple bond is been converted into a double bond over here. Now what is the name of the compound here now? 2-butene. 2-butene. Okay. So to butane is been converted. Now again further, in the presence of nickel catalyst, again when you add hydrogen, one hydrogen atom gets combined with this carbon atom and another hydrogen atom gets combined with this hydrogen atom. So already we have H here. When another H adds, it becomes two hydrogens. The same also here. Already we have H. When another hydrogen atom combined, we get 2O here. Now what does it become? So it becomes as CH3 bond CH2, as one bond, single double bond has been converted to a single bond, and CH2 CH3. Now this is called as butane. What it is called? Butane. So here the triple bond has been converted into double bond, and double bond has been converted into single bond with the help of the reaction called as addition reaction. So in this addition reaction we are adding hydrogen with the help of a nickel catalyst. Now as I told you, the catalyst is nothing but it is used to increase the rate or decrease the rate of the reaction, but it doesn't participate in the reactions here. Now coming to, as if you see in some of the news channels, like we have a low quality of oils, like they use the animal fat as an oil over here. We have some of the news in TV channels and also in newspapers. So why we should not use animal oil or the animal fats over here? We have to use only the vegetable oils. So what is the reason here? If you see, so all the vegetables oil are called as unsaturated fatty acids. All the vegetable oils are called as unsaturated fatty acids, and all animal fats are called as saturated fatty acids. And the nature of these unsaturated fatty acids are liquid at room temperature, that is 37 degrees centigrade. So at room temperature, that is 37 degrees centigrade, they are liquid at room temperature. But when you see the saturated fatty acids, they are all solid at the room temperature. That is why, as our human body temperature is also 37 degrees centigrade, so animal fat, the oil, the animal fat which enters into our body, so as our body temperature is 37 degrees centigrade, it becomes solid. That means it takes more time to get digested over here, and also it is not good for our health. That is why we use vegetable oils which are unsaturated fatty acids, as they are liquid at room temperature, and the animal fats are saturated fatty acids and they are solids at room temperature. Now if anybody come nearest to you and ask what we have to use, which is good for us to use, whether it is a vegetable oil or animal fat. So and vegetable oil is very good. Why? Because it is liquid at room temperature and it gets easily digested in our body. But here solids, it takes more time, and also it is not good for our health. So it creates cholesterol or some heart problem diseases also it gets occurred with these animal fats. Now is it clear with this addition reaction, converting unsaturated into saturated with the help of a catalyst and adding hydrogen atoms over here. Now next reaction, which is called the substitution reaction. So the substitution reaction, in the name itself, is called substituting. So the reaction in which a group of atoms is being replaced by another group of atoms, like a group of atom is being replaced with another group of atoms, so which is called as the substitution reaction. And these substitution reactions are only used for the alkanes. Why? Because they are least reactive, they can be easily divided, and they are also called as paraffins, as I discussed it before. And alkenes are called as olefins, so they cannot be replaced out easily. Why? Because they consist of a double bond over here. Now to break it, it needs more energy. But here alkanes, as they are being single bond, so they are least reactive, they can be easily separated. Now if we take an example of methane, CH4 methane, when it is combined with the chlorine gas in the presence of sunlight, so we get it is been replaced. Once see here, so one of the chlorine attaches to the CH4 over here, so one hydrogen comes out. When one hydrogen and one chlorine comes out, we get HCl, and if one hydrogen is removed, what we get here? CH3, and one chlorine is been added here, so we get as CH3Cl. Again this CH3Cl, again when it is combined with chlorine, one hydrogen comes out from here and one chlorine comes out and forms as HCl, and one chlorine gets combined with this Cl, so it becomes CH2Cl2. Again this CH2Cl2 when combines with again the chlorine molecule, so one hydrogen comes out and one chlorine comes out to form HCl, and another chlorine combines with this chlorine atom, so it becomes as CHCl3. Now CHCl3 is called as a chloroform, we call it as a chloroform. And again CHCl3, when it is combined with the chlorine, the remaining one hydrogen comes out, react with one chlorine atom to form HCl, and the remaining one chlorine gets combined with this to form CCl4, that is carbon tetrachloride. So as 4, that is tetra, so carbon tetrachloride. So all the reactions are done in the presence of sunlight itself, so easily it can be break out. So this is what we call as the substitution reaction, so in which a group of atom is being replaced by another group of atoms, and this substitution reaction is done only for alkanes, so they are also called as paraffins. So paraffins means which are called least reactive or which can be easily broken out. So that is what we call as the substitution reactions. So we have seen about the 4 chemical properties of carbon, that is the combustion. Next we have seen about the oxidation, and next we have seen the addition reaction, and we have seen the substitution reaction over here. Now next, after the completion of this, these chemical properties, let us move on to the preparation techniques of the alcohol and acetic acid. So let us see how alcohol and acetic acid are being prepared and what are the properties over here. So let us move on to that. So the preparation of ethyl alcohol, or also called as ethanol, also we can call it as ethanol. So ethanol, the formula is CH3 CH2OH, or also it can be written as C2H5OH, which is the another formula which can be, this can be modified into this. So the preparation of ethyl alcohol, which is also called as ethanol. So how can we prepare ethyl alcohol? So it can be prepared in 2 ways. One is in the chemical process, and another one is the natural process. So let us see the chemical process over here. So first we have the ethene, that is CH2 double bond CH2, which is called as ethene. So as we have a double bond, when it is been reacted with the vapors of water molecules, when it is been react with the vapors water molecules, the vapors, in the presence of catalyst P2O5, that is phosphorus pentoxide, we call it as P2O5, phosphorus pentoxide, and in the presence of the atmospheric pressure, that is 100 to 300 atmospheric of pressure, and having a temperature of 300 degrees centigrade. Now what happened, this ethene gets converted into alcohol, that is when H2O gets combined with this, so it converts into CH3C2OH, or simply what we can write this equation as, here we have C2H4, so this as 2 carbons are there, so C2 and H4. So when it combined with H2O, when it combines with H2O, already we have C2 here, so C2. So one of the hydrogen gets combined with this hydrogen, so we get H5, and the remaining we have OH over here, so we get OH, or it can be written as C2H6O also. Sometimes to get confused, they can be written as in the form of the carbohydrate form, that is C2H6O. It can be written as like this also. So this is also the formula for ethyl alcohol. So this is also the formula for ethyl alcohol. This is also the formula for ethyl alcohol, which can be written in 3 different manners. So don't get confused with what the exact formula is. It can be written as 3 different forms over here. So we have prepared an ethanol in the presence of a catalyst over here, that is phosphorus pentoxide, with a certain atmospheric conditions, that is 100 to 300 atmosphere, and at a temperature of 300 degrees Celsius. And next, this is the chemical process. With this chemical process and the natural process, which we call as the fermentation process, that is the converting of starch and sugar into alcohol, that the starch, the sugar what we have, the converting into the alcohol is called as the fermentation process. So we have a general equation over here, that is the cooking grains which are called as starch, and we mix the sprouted barley which is also called as malt. When they are mixed together and being stored for a long time, we get glucose. And when the yeast is been mixed here, and when it is stored for naturally, like for 1 year or 2 years naturally, when we store, we get ethanol plus carbon dioxide gas has been released out over here. So this is the natural process which we call the fermentation process. So two processes we have to prepare the alcohol. One is the chemical process and one is the natural process. And let us see the physical properties over here. So the physical properties of ethyl alcohol is, it is a colorless liquid and a sweet odor, that is a sweet smell we get here. So it is a colorless liquid and a sweet odor, and it boils at 78.3 degrees centigrade. That means at this temperature it gets evaporated, and the pure ethanol or the pure alcohol is also called as the absolute alcohol. It is also called as absolute alcohol. And next, the denatured alcohol. The denatured alcohol. What is a denatured alcohol? Natured, denatured. Natured, denatured. You might got an idea about what is natural and denatured. So denatured alcohol is the ethanol that contains impurities which makes undrinkable. That means we cannot drink it at all. So that is called as denatured alcohol. So denatured alcohol have the sum of the impurities. Those impurities such as methanol, isobutyl ketone, aviation gasoline. So these are the some of the impurities which are present in the denatured alcohol. So these are not used for the drinking purpose, but these are used for other purposes, like in motor fuels and some other purposes we use it, like motor fuels and aviation gasoline, that is in aeroplane we use it as a fuel. So in other purpose, and here the solution of 10% of ethanol, the 10% of ethanol is in gasoline is used as a good motor fuel. So in good motor fuel we have 10% of ethanol over here. So as 10% of ethanol is used as a good motor fuel. And next, as ethanol is a good solvent, it can be mixed in water also or any other liquids, that is a polar liquids. So it can be used as in medicines, that is to make tonics, to make syrups. So as ethanol is a good solvent, that means it can be easily mixed out. So it is used in tonics as well as syrups also, and it is also used to make tincture iodine. So it is also used to make tincture iodine, that is a tincture solution. When doctors when they inject injection, they first use it to rub the tincture. So it is used as a tincture iodine also. So these are the physical properties of the alcohol, which is the colorless liquid, sweet odor, boils at 78.3 degrees, and denatured alcohol, which is not used for drinking, and the 10% of ethanol is a good motor fuel and a good solvent of as it is a good solvent, it is used in medicines to prepare tonics, syrups and tincture iodine. So this is about the complete information about ethyl alcohol. Here we have seen about the physical properties. Now let us move on to the chemical properties of ethyl alcohol. So the ethyl alcohol properties, as we have C2H5 over here. So as we have C2H5, which is called as ethanol. So when the ethanol is react with the sodium, when it is react with the sodium metal, so it converts into C2H5OH, C2H5ONA plus H2, hydrogen gas is released out. So which is called as sodium ethoxide. It is called as sodium ethoxide. So here the hydrogen which is present in the hydrogen which is present here is being replaced with the sodium atom. So the hydrogen comes out and the sodium enters into here and form as C2H5ONA, and the hydrogen which comes out, the hydrogen gas which is being liberated out over here. So this is the sodium ethoxide. And another chemical property we have as ethanol C3H2OH in the presence of, that is at the temperature of 170 degrees, by adding few drops of concentrated H2SO4, that is a sulfuric acid. So the water molecules get out over here, which is called as dehydrates, which it gets as the H2SO4 dehydrates the alcohol and forms CH2 double bond CH2 over here, plus hydrogen water molecules been removed out. It is just same as how we use in the preparation of here, like reversible, as we use water vapors over here to form alcohol, and to remove those water vapors in this we use concentrated H2SO4, which gets dehydrated and the water molecules get out, and we get CH2 double bond CH2, which is the ethene. Now let's move on to another preparation, which is called ethanoic acid. So ethanoic acid is also called as acetic acid, and the formula is CH3COOH. So the preparation is as we have done in the oxidation reaction, that is CH3CH2OH ethyl alcohol. In the presence of these oxidizing agents, we get ethanol, and again oxidizing we get acetic acid over here. CH3COH acetic acid is been prepared out. So sometimes in CH3COH can also be written as C2H4O2. C2H4O2. So remember that C2H4O2 is also called as the acetic acid over here. And coming to the physical properties, so what are the physical properties? It is a colorless liquid and unpleasant odor. That means we cannot get smell it. It is an unpleasant odor, and it is easily soluble in water, and it is also less acidic. So less acidic, very weak acid, we can call it as weak acid over here. And 5 to 8% of the solution of acetic acid in the water is used as a vinegar. That is, in a liter of water, so when we take 5 to 8% of a solution of acetic acid, then it converts into a vinegar, and it is used as a preservative of pickles, the pickles which we are getting from the stores. So they are a little bit sour taste, so that sour taste is due to the presence of vinegar, and this vinegar is prepared as 5 to 8% of solution of acetic acid when it is mixed with water. So these are the physical properties of ethanoic acid or acetic acid. Now coming to the chemical properties of acetic acid is same as for what we have for the chemical property of ethyl alcohol. When acetic acid is react with the sodium metal, so we get CH3COONA, that is the H hydrogen is been removed out and the sodium is been replaced out over here. And CH3COH, when acetic acid is react with sodium hydroxide, which is a base, so when it gets combined we get CH3COONA plus H2O. As this also we called as a neutralization reaction, which comes in under the acids and bases topic over here. And CH3COH acetic acid, when it reacts with the sodium carbonate Na2CO3 sodium carbonate, it converts into CH3COONA plus H2O plus CO2, carbon dioxide gas is released out. At the same time as sodium hydrogen carbonate, or also called as sodium bicarbonate, or it is also called as baking soda. So when it is reacted with acetic acid, CH3COH acetic acid, so we get CH3COONA plus H2O plus CO2. If you see in all the chemical properties, we have a common term here, that is CH3COONA, which is called as sodium acetate, and this sodium acetate is used in a soap, the preparation of soap. It is used to prepare the soap solutions over here. Now is it clear about what we have discussed? So we have discussed about the preparation of ethyl alcohol. One is the chemical process, and another one is the natural process, and next is the physical properties of the ethyl alcohol has been seen, and we have seen about the chemical properties of ethyl alcohol. Next, coming to the ethanoic acid, that is the preparation of acetic acid and the physical properties of acetic acid, and also the chemical properties of the acetic acid has been watched out over here. So right now we have discussed about the combustion reaction, the oxidation reaction, addition and substitution reaction over here, and we have seen about the preparation of alcohol and acetic acid. So based upon this, if you have any doubts regarding, please give your valuable comment. Thank you for watching the video. Thank you. Please subscribe the channel. If you are not subscribed, please subscribe the channel. Give a like button. So subscribe, give a like button, and give your valuable comment, and more interesting videos will be uploaded further. So right now, thank you for watching the video.